Introduction to engineered single-stack waste and vent systems. How similar they are and how they are still used by national plumbing codes.
This presentation will include 8 learning objectives. What is a single-stack engineered system? The history of single-stack systems. Does it work much differently than conventional plumbing? Does it have a proven track record? How simple is it to design single-stack DWV riser drawings? Does it reduce labor and material costs and install faster? Does the system have National Plumbing Code approvals? When should engineers consider using this type of system? This is the most important thing for a plumbing engineer to consider after receiving the questions and answers found in this presentation. The plumbing engineer is the only professional according to the Plumbing Code that can design and stamp the approval of a single-stack system. What is a single-stack system? The single-stack, also commonly known as a wet vent system, is based on the theory that the drain lines will be of sufficient size to accommodate the 3 factors involved in any drainage system: solids, liquids, and air. In the city of Philadelphia, a single-stack system was developed using these principles. The Philadelphia single-stack plumbing system does not require, nor does it depend on any special type of drainage or vent fittings. However, there are branch line developed length limitations, and the size of the stack is often too large to fit in common plumbing walls. The engineered single-stack system we will discuss today uses 2 fittings to control the velocity of water in the vertical stack and reduce the hydraulic jump when the piping changes from vertical to horizontal. There is also a single-stack system listed in the IPC code that uses long sweep or combo type fittings used in smaller multi-story buildings. Also, there is an approved combination waste and vent method shown in IPC section 912. The history of the single-stack plumbing. The single-stack system is an engineered drainage and vent concept for multi-story buildings of any height. It involves 2 primary fittings, the aerator or stack vent and de-aerator or base vent, in conjunction with the normal approved standard DWV pipe and fitting materials. The system was developed in Switzerland in the 1950s and represented one of the first times a scientific approach was taken for the protection of trap seal loss in sanitary systems. The hydraulic and pneumatic characteristics of intermittent flow were studied using a 10-story testing tower, complete with measuring instruments. It was found that controlled flow velocities reduced the excessive pressure excursions that can occur in conventional systems without revents. The unique interior of these 2 engineered fittings provide the control and will maintain internal pressures acceptable without using any revents. These 2 special vent fittings are the most popular single-stack systems used in Europe, the United States, and Canada. They provide both venting of the wastewater flow for both the vertical stack and the horizontal drains. Different single-stack systems installations. Single-stack technology was developed by Fritz Summers in Switzerland in the 1950s. Once perfected, the single-stack system was marketed to other industrialized countries around the world. Developed initially in cast iron, single-stack was introduced to the United States in the mid-1960s in the form of DWV copper. In the 1970s, a no-hub cast iron version was developed that offered standard no-hub band connections and became successful in hotels and high-rise apartment buildings. In 2008, a single-stack fitting was developed using PVC materials, allowing use of a system for mid-rise residential, wood-constructed hotels, and high-rise towers, replacing both the heavy and expensive cast iron piping. Europe and Asia started installing high-density polyethylene single-stack systems. Geberit is a German company that uses similar type fittings, only made with polyethylene fittings and piping for projects in Europe and Asia, but they require electronic welded joints and the HD polyethylene material, and this is not approved to use in the United States. Conventional DWV plumbing water plugs. The basic design of conventional DWV size piping can create what we call water plugs inside the piping, causing either siphonage or back pressure. A separate vent or revent must be added to provide air into the wastewater piping, allowing it to flow freely inside the water-filled waste pipe. The following slide will demonstrate how water plugs can form in conventional DWV piping and how revents provide air, preventing these water plugs from siphoning or blowing out plumbing traps. Conventional systems with uncontrolled waste flow velocity. Velocity flow close to inlet. The open airway in the center of pipe permits normal airflow. Velocity increases with vertical drop. The increase in water flow velocity causes the thickness of water flow to build up. Terminal velocity. The air opening is completely closed, forming a water plug. This causes siphonage or back pressure unless the branches are separately revented. These water plugs can form in conventional plumbing inside the horizontal DWV piping, but can be unplugged by installing an additional inline vent to provide air, allowing a full pipe to easily flow without affecting any trap seal losses. Interior view of the two main fittings. The aerator or stack vent. We have stack inlet, velocity breaker offset, branch vent, branch baffle, separation shield, velocity breaker offset, collection chamber, and stack outlet. On the de-aerator or base vent, there is an inlet, a relief vent that controls back pressure, a nose baffle that controls velocity, and an outlet. These are the two special vent fittings used by ProVent PVC and Sovent cast iron. Also, the engineer's design and pipe sizing allow the system to properly vent all the vertical and horizontal piping. How to control waste flow velocities. Here's a stack with a stack fitting showing air in the middle. Maximum design flow of branch drainage never exceeds 1/2 full flow conditions at the inlet. The stack length never exceeds 20 feet without either a stack fitting or a velocity breaker using an inline offset fitting. The stack maintains the proper air mix. This chart shows that by controlling the waste flow velocity, the single stack allows more DFUs per stack than conventional piping because of its design. Chart 3 shows maximum loading by the stack. A 3-inch stack will allow 64 fixture units on it. If the building is over 7 stories high, you can go up to 102 fixture units on it. The 4-inch allows 504 fixture units. The 5-inch is 1,010. Stack fitting is required at every floor when the connecting branch piping is 2.5 inches or larger in diameter. IPC and UPC single stack DWV approved design. IPC and UPC has an approved single stack system providing a similar type of combination waste and vent system which allows a single stack with many limitations. It allows just wastewater to flow through this straight stack. This approved system is still used now in many apartment buildings, but notice all the piping limitations. It's a straight stack and cannot have any offsets and cannot discharge water closets, urinals, or disposals. There are no offsets permitted, and it has to be sized uniformly throughout its length. This shows the IPC Section 912 Combo Drain and Vent System. This system permits waste-only fixtures to discharge into the IPC Combination Waste and Vent Stack System 912 without using revents, but has many restrictions. If the stack vent fitting was used, this system would have only a few restrictions. The IPC Table 912.3 shows the 3-inch single stack connection limited to 12 fixture units, and the 4-inch stack is limited to 20 fixture units. Compare this when using a stack vent fitting at each floor. Chart 3. Loading by the stack shows 64 fixture units for a 3-inch stack and 102 fixture units in apartment buildings over 7 stories, and 504 fixture units for a 4-inch stack and 2,200 fixture units for a 6-inch stack. As you can see, the approved IPC drain and waste system with limitations is basically the same design as the single stack system. The only difference is the single stack method adds a stack fitting at every floor and a base fitting where the vertical stack goes from vertical to horizontal with only fixture unit limitations. The single stack uses only design airflows in branch piping. Here, we are showing a typical back-to-back installation. Typical branches are coming from the stack fitting to 2 water closets, 2 tubs, and 2 lavatories. The single stack design flow is less than 50% of capacity. Single stack allows the waste to be vented through the top of the branch piping. The ProVent design can also be compared to the IPC and UPC code-approved circuit venting that allows the air on top of horizontal pipe, shown here, to be used as a vent for branch connections. IPC and UPC allows for circuit venting. Circuit venting allows up to 8 floor outlet fixtures with a single vent. The basic IPC principle behind a circuit venting system is the horizontal flow of the drainage never exceeds half-flow water conditions inside the pipe. The air is used for venting all 8 fixtures and circulates within the top half of the pipe. The flow from the fixture branches is slow enough to prevent any siphon effect to the battery of 8 traps connected to the floor outlet fixtures. The drawing on the right-hand side shows the 8 water closets in a battery-vented condition. This approved IPC Section 7.101 and UPC Section 911.1 circuit venting also justifies the same single stack method of venting the branch connections. This shows multiple branches into one branch opening. The single-track system functions on the same principle again by using the air circulating inside the top of the horizontal branches to allow a combination of horizontal drains to drain into one single branch, as long as the one 3-inch branch doesn't go over 13 DFUs. The detail on the right shows a combination of 3 branches totaling 5 fixture units draining into one branch. Single stack chart 2 shows there can be up to 13 DFUs into one 3-inch branch. IPC Table 7.1 shows 20 DFUs can discharge into one vented branch opening. Both methods will drain the same way, only the single stack can drain more than one branch, but not more than 13 DFUs. The single stack base and PRL fitting. Because of the hydraulic jump at the base of every stack, the pressure relief line shall not be tied into the horizontal drain any closer to the stack than 10 times the drain diameter. This is measured from the center line of the stack to the center line of the PRL-Y connection. Tying the PRL into a 4-inch drain would require at least 40 inches from the center line to the stack. The de-aerator or base vent fitting will reduce the hydraulic jump, providing a smooth flow into the main drain. The PRL vent line will balance out any back pressures inside the pipe. This same base or de-aerator fitting is also used for venting when stack offsets are needed when bathrooms are moved to a different area from the floor below. The base fitting controls the flow and hydraulic jump. This detail shows how and where the PRL vent line gets tied in above the elevation of the main drain, compensating for any negative or positive pressures inside the drain. The nose baffle compensates for back pressure and lowers the hydraulic jump. The stack and the vent are in the same wall. Connecting the horizontal branch drains. Branch waste lines must enter above the branch line within the 10 times stack diameter. Branch waste lines connect anywhere upstream from the PRL line and connect with the branches rolled up as shown here.
Read what we have learned so far. The first set of slides were intended to educate engineers about how the ProVent stack works by using its built-in offsets, air vent, and a collection chamber that flows into the stack just like a conventional cottage stack T-fitting. We learned single stack horizontal branches connecting into the ProVent stack opening by venting branches the same way as the half-full pipe concept known as circuit venting, shown in chart in section 710.2 in the IPC plumbing code.
The base fitting using roll-up branches. Here, we are using the branch drains rolled up when discharging into the main drain. See the branch detail showing the wastewater in the branch discharging into the open airspace on top of the main drain, producing a smooth flow. The detail on the right can be used in the underground or in the collection area above the ground floor. Flat branch openings. When branches cannot be rolled up due to elevation, flat branches can be an alternative. However, they can only be tied in 40 inches beyond the stack itself and can be laid flat, but with pitch to the 3 branches shown here. Stack offset piping connections. When offsets occur on the upper floors, the PRL vent line must connect into the vertical stack and not into the horizontal piping. If the stack offset can be made with a minimum 60-degree fitting or less, they are not considered an offset, but considered a straight stack, which is shown here on the right. On the left, it shows the tying in of the PRL line on the vertical stack as opposed to the horizontal. The branch lines still have to be rolled up as shown here. When most people see lavs and sink connections, they say, "Hey, that's an S-trap." S-traps are not permitted in modern plumbing codes. They used to be permitted years ago, but have since been outlawed. S-traps are not permitted in single-stack systems. A trap is only an S-trap when the trap and the drop leg of the assembly are both the same size. The drop leg fills up with water, causing a water plug that can siphon the water seal in the trap. Single stack designs do not allow this type of siphonage S-trap. This trap is permitted when the drop leg size is 2-inch or 1 pipe size larger than the 1.5 or 1.25 trap. The larger size drop leg will not create a water plug inside either a 2-inch or 3-inch size drop pipe. The single stack design does also allow a 3-inch drop leg on a 2-inch trap for a washer box. This will prevent any siphonage by oversizing the drop leg by 1 or 2 pipe sizes. Special designed single stack P-traps are permitted. Code allowable trap loss. All DWV approved systems allow the admission or emission of air so that the seal of any fixture trap cannot lose more than 1 inch of water column as shown. It is also contained as a requirement in IPC Code Section 901.2. This shows the area of trap seal loss in a typical trap. The single stack system has been tested using 1 pipe size larger in the 10-floor testing facility and passed the 1-inch maximum trap seal drop test. Plastic DWV risers need expansion joints. PVC stacks require expansion and contraction joints on the PVC risers. The above expansion joints are flexible coupling type fittings expressly used for PVC DWV stacks in multi-story buildings at every floor or every other floor in accordance with the structural engineer's instruction charts and can be installed without access panels. If the DWV single stack system uses PVC or ABS piping, it must use the proper type expansion and contraction joints in accordance with both the plumbing and building codes. Location of EZ Flex expansion couplings. This photo shows the proper location of the expansion joint because it not only works for expansion and contraction, but also works for ease of installing the stack fitting in between floors and shows a pipe guide located below the expansion coupling. Conventional vents can connect to single stack vents. Many hotels and apartments now have commercial space on the first or second floor. This illustration shows how to connect any vents coming from conventional plumbing in other areas and can tie into the single stack, usually connecting on the floor above with the vent connection looking up on a 45 as shown. Conventional plumbing from another area connected to single stack plumbing shown here on a 45-degree angle. Required use of a stack fitting for soil connections. A stack fitting must be used when the connection is from a soil pipe or when the waste opening is the same size as the stack or one pipe size smaller. This is in accordance with the engineer's design manual. A 2-inch waste branch can be directly connected to a 3 or 4-inch stack. A 2-inch conventional plumbing vent can be connected to a 3-inch ProVent stack and a 3 to 4-inch stack. How to add an additional stack from upper floors. This illustration shows how to add a new branch stack connecting to the original stack by using a base fitting to reduce the flow of wastewater from the above stack before entering the original stack. 2 3.5 gallons per flush and 2 1.6 gallons per flush water closet connections. Only 2 water closets may connect to a common 3-inch soil branch. Increase to 4-inch pipe size when downstream fixtures are added or when using 3.5 gallons per flush water closets. The type of toilets used can change with the size of the piping used. Connecting back-to-back pressurized water closets. These illustrations show how to install pressurized back-to-back water closets to prevent them from blowing the pressure back through to the other side of a sanitary cross-fitting. The IPC Section 706.3 requirement is to use a double TY type fitting or have a 36-inch center-to-center developed length between the 2 closets. This rule would apply to conventional plumbing or single-stack plumbing. The drawing shown on the right-hand side shows how to develop the 36-inch developed length using the ProVent method. Approved branch length openings. This chart shows the horizontal branch lengths of 4, 3, and 2-inch pipe can run excluding any vertical piping. Telescoping pipe sizes is permitted. Telescoping larger piping with smaller piping is permitted to increase the length of the branch piping. If a 2-inch branch needs to be 18 feet, a 3-foot piece of 3-inch pipe can be added downstream from the 2-inch to allow the 2-inch 15-foot branch to become an 18-foot branch. 4-inch can also be added to a 3-inch to extend its length. Lav or electric water cooler details and washer branch piping. Here, we see the details of lavs, sinks, and water box connections. If a fixture is connected downstream from the washer, it must increase one pipe size as shown in the middle image. ProVent recommends 2 drops on back-to-back greasy waste kitchen lines because it serves different tenants. See left drawing. Lavs can have back-to-back lavs with 1 drop. See upper right drawing. Vertical pipe rules. Drop lengths can become a problem when the drop goes from vertical to horizontal, creating a hydraulic jump. The drop may be longer when having a smoother flow to the horizontal drain. See number 2, shown with 245s or use a Y and 1/8 bend shown in number 3 and number 5, or increase the size of the horizontal drain as in number 4.
Read what we have learned so far. S-traps are not permitted by plumbing codes. However, the ProVent P-trap has a different configuration with a larger drop leg that connects to the U-bend trap and prevents any water plugs from forming and is accepted by the IPC and UPC. 2-inch size waste or 2 pipe sizes smaller than the stack can tie into a stack fitting or aerator fitting. We learned pipe length rules, vertical drop pipe rules, and water closet connections.
Market Square Apartments project in Indianapolis, Indiana. The first 4 floors of this project were for car parking only. Apartments start on the 5th floor. For this ProVent apartment project, the first 4 floors were parking decks without any plumbing. This is where inline offsets could be used, or the stack pipe could be increased by 1 pipe size. No branch connections needed on floors below. The left side of this slide shows the double inline offsets every 20 feet and can be used instead of a stack fitting. Usually, when there is no plumbing, it's because of parking decks on lower floors or various floors that have no plumbing. Also, the stack could be increased 1 pipe size from the lower level to the collection area as an alternate. Special fittings for back-to-back layouts. This special 3x2x2 double Y shown here is designed to fit perfectly between the stack fitting and water closet in order to pick up 3 fixtures using 1 fitting with special raised rolled swing branches. New fittings speed up piping installations. When should single stack design be considered? Single stack systems are not practical to use for most buildings. Single stack systems are used mainly for multi-story apartment type units with bathrooms, kitchens, and laundry rooms above each other on every floor. Single stack DWV design should also be considered in any multi-story building with at least 3 or 4 more floors. Single stack designs should certainly be considered when conditions like this occur. There is no reason not to consider it. Savings will vary from layout to layout. Sample ProVent drawings are available to compare between single stack and conventional plumbing. How the single stack reduces plumbing costs. Considerably less labor and materials. Saves approximately 1/2 of all pipe and fittings used in conventional plumbing. Eliminates most inserts, rods, and pipe hangers. Offers versatile branch joining possibilities. Reduces stack sizes with the same loading capacities. Saves more space and completes the DWV system faster. Easier design layouts for piping and DWV stacks. Consistent layout designs from project areas where the rules never change. Consider each of these items that show the reduced cost over conventional plumbing. The next 3 slides list many more benefits. More cost reasons to use the system. Item number 1. Most project schedules are now fast track. Single stack allows plumbing contractors to stay ahead of these schedules. Item number 2. Less pipes equals less penetrations and fire stopping. Item number 3. Less pipes equals more space for coordination with other trades. Item number 1 was the most important surveyed item noted by both general contractors and the owner. Here's more reasons. Can be used in order to help save owners' budgets. Promotes engineering firms as being innovative and proactive in saving both time and clients' budget. Easier plan reviews with code officials and inspectors. Works even better with modular construction both off-site and on-site. Conventional DWV systems can connect to single-stack vents from lower levels in most projects. Modular construction is using single-stack plumbing more each day. Single-stack systems code approvals. Approval from the AHJ, can be obtained by the engineer's Alternate Materials and Methods section of Model Codes by the IPC Codes Section 316 and 701-B. Alternate Engineer Design. The design, documentation, inspection, testing, and approval of an alternate engineer design plumbing system shall comply with sections 316.1.1 through 316.1.6. The UPC Code, Section 301.4, Appendix C, Alternative Engineer Design. An alternative engineer design shall conform to the intent of this code and shall provide an equivalent level of quality, strength, effectiveness, fire resistance, durability, and safety. All single-stack manufacturers are willing to assist in gaining plumbing approvals in any questionable local code areas.